Okay, so we're now doing examples in velocity versus time graphs. So for this first one here, we want to find the velocity at 2 seconds. So it's just a matter of, again, we've got velocity here and time seconds on here. So at 2 seconds, we can just read off the graph that the velocity was 8 meters per second in positive direction. Okay. So the acceleration between 0 and 4 seconds, so in your notes above, acceleration is equal to the change in velocity over time, which is equal to the rise over run for this graph. So between 0 and 4 seconds up here, this is going to be 16 up there. And so we've got our rise up here, rise equals 16, and our run, obviously equals 4. So that means that that's equal to 16 over 4 equal 4 meters per second squared in positive. Okay, so these times with the velocity versus time graphs, if you have a straight line like this, like it's just a straight linear graph, then it's going to be it's going to have constant acceleration because the velocity is increasing at the same rate. So the total displacement between 0 and 4 seconds, so to find it out, you have to work out the area under a curve. And that's because if we rearrange our velocity, average velocity is equal to displacement divided by time. So therefore, if we rearrange that, then the displacement is equal to velocity times time. So if you have velocity along here and time along there, then velocity times time is equal to area. So equals area under curve. Okay, so because it's a triangle, it's going to be equal to half times base times height, which is equal to half times 4 times 16, which equals 32 meters in positive direction.